Okay. That's going to be fun all that's going to be fun all week. But anyway, uh, so if I was the chair, oh, okay, there. What what do I what do I do to
Okay.
share my?
It is one of these buttons up here, I think. Are the presentations loaded into
Yes.
try?
So meeting materials, yes.
Actually,
No, this is good. This
oh
is
no, I
good.
think you do the share screen thing, and then you can share the slides
Yeah.
from there.
Let's see, this is the agenda. Fabulous. And oh, and I'm sharing slides. Okay, great. Um, and I also want to share my screen for now.
Let me go. Let me go find somebody.
Oh, I'll just keep messing with it. You know me. And yes, we are still getting slightly organized. We are most of the way there, but we are not all the way there. So if anybody would like to come up and it's going to be speaking, come up and make sure that everything is okay for them. That will be great. And I look forward to knowing what the answer is very soon. Okay, I'm getting stupider.
Okay, you have slides.
Um, okay, so I stupidly, this is where you say stupidly, um, I did the thing where it's like, oh, I'm not going to be using my camera or my audio, so I didn't authorize those things on the way up.
Ah.
And for extra credit, um,
Should you maybe step out and step back in?
I logged out and logged back in, but it did not restart my browser and stuff. Let me do that.
Well, hold on. Before we try that, let's see.
Yeah, see, this is what I'm getting because it's not refreshing that. So that's irritating. Yeah.
Did you join the regular one or the light version?
Regular.
So I think the audio, like it shouldn't be doing audio through the computer because it's got its own setup.
Yeah.
So just for slides, right?
Yeah.
Okay, so can you go back to the Medico thing?
Yeah. Um, so if I was doing this and
Oh, ah. Did you do something?
okay, this is me.
Okay.
And then I say meet echo.
Okay.
There. Yes.
Okay, so request browser permissions.
And that's
Okay. Hit complete anyway. We're gonna, because I think that the audio should be through.
yeah. I just need to be able to turn the video on. Basically.
There should be cameras on you right there.
But I'm saying to share my screen.
Right. So, so click on.
See, I don't see.
That's to share slides.
Right.
Okay.
So,
And
oh,
choose
okay,
the one you
okay.
want.
This is what I'm looking for. Okay, excellent, cool. Okay. And okay. So one more. Let's see. What do we got? I could at least do this, and people could start doing the sound
On
check
this side.
on that side. Okay,
This
excellent.
side will show the queue if anybody remote has the video. It'll show that.
Okay, cool. Okay. So that is interesting. And it was a year. It was a year. It was a year. It was a year. Okay, so we have this.
Yes.
And what I was hoping to do was to also share hopefully this. And yeah. So I wanted to show this also. And this is HTML. If you didn't believe it.
Okay, it needs to be shared to Medico. You need to save it into Medico first.
Okay.
So like you can PDF that document.
Really?
Objectives are on there. Yeah, yeah. That's the part for you to worry about. How do I get this working? This is working. Okay, let me know if you need me. Yep, thank you.
Okay, that's HTML. And I want to. You guys can do this. Literally anyone can do this so much better than I can. I want you to download this as PDF. Yes, which is there. And I want to upload that. Yeah, that's where all the other ones came from. Yeah. I'm sorry. Oh, I have had a request since we are in a meeting room for people to go ahead and put masks on, which I think includes me. If we would take a moment to do that, that would be great. Let's say upload new slides. And this is a agenda.
Yeah, but you can do that just what I did. So yeah, it's all good.
Okay, so I am there. So then in Medeco,
It may not show up immediately in Medico, but I can show you how to get it if it's not there.
okay, and so then I would just go, not there, but
Are you trying? You wanted to share the thing that you just uploaded?
yeah. And cool. So what do I need to do now?
Well, actually, click on where it says agenda.
I'm sorry?
Okay, so you may be able to just do that.
Mm-hmm.
Is that the same one? Or no, that is not. Okay, that's so go
That-
back.
And, yeah, yeah.
Okay, so go to the highlighted thing where it says, yeah, share that.
Oh.
Pleasure, and you're going to share again.
Okay.
And we're going to share the agenda.
Okay.
If it's not in here, because sometimes it doesn't happen immediately, then we will manually add it.
Yes.
I need you to do a clean logout and login because you have been recognized as a chair for this.
Oh, okay, okay, okay. That, and that is a logout of the data tracker?
So from here, just
Yeah.
dismiss this window through the door here.
Oh, okay.
Leave the room cleanly, okay,
Okay.
exit, and then you can join again. And your role should be set.
You're amazing as always.
Envelope is just one floor down.
It would have been helpful if you'd known that we were standing here. It's not really Thank you.
Well, I was trying to get logged in enough to where I could just say meet echo when magic occurs.
Maybe in the next week.
No, no. We're still getting that.
Yeah, that's not a problem. It's it doesn't find your webcam.
Yeah, but yes, you're right. One of these days, I'm going to have to figure out how to clear that, but it doesn't need to be this week. And so I'm going to. Oh, sorry, there, and there.
Second one from the left, under your name.
Yep. Oh, okay, cool.
And then find it if you want to share.
Okay. Oh, and this is actually working better than I think it is because.
Click on the name in preview pops up.
So, yeah, I'm actually looking. Let's see. But those are chair slides.
Okay, I'm guessing that because that was uploaded so very recently, it's not in here yet. So we're gonna try something else, okay?
Okay. So, yes.
Okay.
I'm just
So
making sure I got that.
The
Okay.
little wrench icon. Yeah, that one.
Yeah.
And then manage slides.
Okay.
And then you are going to. This is where mine might be different from yours. There should be a thing to upload something manually here.
Is the deck that you're trying to find in the data tracker?
Yes, I was just talking about it.
Oh yeah, so we were just trying to the refresh button there.
Oh, okay. Cool.
This refresh is going to use the tracker. And now you should find it among one of these
Okay.
ones. So let's find it and then we can upload it.
Okay.
Let's first find the deck that you're looking
So-
for here among these.
Well,
Which one you are.
Well, and I don't actually either, so that's what I need to. That's what I actually need to find. So. What did I call that? Is this it? No, this is not what I. Anyway, we'll figure this out another day. We probably screwed around long enough.
Yeah, I know. I got to did that track. It's not this one.
But that can be for different reasons. Yeah. No, I think I have two different things that are both called chair slides. So I actually need to be able to do something. How do I turn this on? Are you all smart? Yeah, that's the clicker.
Trying to complicate things too much.
Hi.
How do you normally change pages on this? Is this just page up, page down? That's the Chromebook going
It may be good for me to hand this back to you and let me just discuss slides.
If you have another one that works with the Chromebook, then that's better. You have. Sorry, I was trying to help.
Oh, that's cool. And you did, and you did. I think I have an aneurysm.
That's not allowed.
That's not what I want. That's not what I want. That's not what I want. I need to have an aneurysm, I swear. So I want to start. Okay, I want to start with my slides. And let's make believe that's this. Oh, there's the agenda. Okay, that did happen. Okay, good. So I'm importing that. Oh, do I need to import all these before I share them?
Go all the way down. You need to close the window, right? All the way down.
Yeah.
And now you should find the device that you can share.
Okay. So am I? We're doing that. Okay, great. And so I think we are ready to start triumphing over technology. And do you have a? No, I got, and I do not have one. Stuart did, but let's go ahead and the rest of the world will thank us for having these. But cool. I think we can roll from there. Thank you. So I apologize for the extended vacation in here, an opportunity to talk with each other. Let's go ahead and get started. My name is Spencer Dawkins.
Mike, too slow, too low. Louder.
Are you guys hearing me now?
Yeah.
Cool. I will eat the mic. So welcome to HOTRFC. I want to thank Aaron Falk, who is for like the last well, this is the 10th. This is the 10th HOTRFC talk. And he has done all the work on all of it. So let's see. I should also mention that he's not able to be here with us this time because he has COVID. So, I'm sorry? I'm sorry. Yes, I'm sorry that Aaron is not able to be here with us, but like I said, he has done HOTRFC, all the work on it for 10 HOTRFC talks, and we owe him a round of thanks for that. We should applaud. Cool. And oh, right. I really do need to use Meet Echo more often. Oh, I do. So the ground rules, HOTRFC is a request for conversation. It's the good way to find people to talk to for various reasons, and we don't actually care what the reasons are. Each person who's going to be speaking gets 4 minutes from go to please applaud. At 4 minutes, we start applauding, which looks like this. And the crowd goes wild. So when you're speaking and if you happen to hear people applauding, that is your opportunity to recognize what a great job you have done and pass back the microphone to the next speaker. We don't do questions after each talk here. That basically the thing with HOTRFC is that this is where you come and you provide follow-up. So basically saying what you want people to do and how you want them to find you to do it is part of each talk. To follow along, we're going to be using the data tracker for all slides. So we will let the conversations begin. And first speaker we have will be Torlis, who will be talking about what has the IETF ever done for energy. Give me a second to get slides up and to start a clock.
And I'm removing the mask because my accent is worse enough already. I hope that's fine. Still louder? Okay. All right. People on the back falling over? Okay. Yeah, I hope it's okay to remove the mask while I'm here on the microphone because my accent is already bad enough. And I don't need a microphone to make it worse. And maybe if we can get the levels up, that would help people to really not eat the mic. Not sure if the technician is still here. While Spencer is still working. And going.
We'll take a second.
Going. A deck may be shared with the remote audience, but not the room.
I would not be a bit surprised. Charles, where is your deck?
When I was going through it, I was seeing it. I could click on it.
You're looking for what has the IETF ever done with? There we go. Perfect. Okay. We are sharing slides. Give me just 1 second to start an official timer.
Okay, there's going to be an official timer. Okay.
On your marks, get set, go.
All right, welcome everybody. So we started to think about what might be interesting to do about energy, green networking, sustainability, and so on. And then you step back and say, well, you know, what is already been done in the IETF. And when we started to write this together, it actually went through a lot of different areas, which reminded me of really the Monty Python, The Life of Brian, right? So what have the Romans ever done for us? And you know, you start with, oh yeah, the IETF, that's just LLN, low power networks, IoT, that's all, it's energy related. And when you then go through what the IETF, and I think it's a lot more. So the purpose of the document is to become maybe an individual submission document for education of the community and to help you know, steer interest in new work, but also to broaden the adoption of the specific technologies mentioned. Now, I'll just you know, show you here the content of the document. A lot what I think really helps preserve energy from the IETF work is really incidental, meaning all the technologies we've done to some extent do save energy compared to their prior non-digitized solutions. And then the other part that really made the IETF technologies become very energy saving is the saving through scale, right? Building the internet, converging all these different separate network application into one network. So those things are big areas in the document. And then looking into specific applications like telecollaboration, computing with sustainable energy. So they're really specific areas, I think, of interest. Obviously, I hope I'm missing big areas and people will jump up and say, you know, we can contribute other stuff that incidentally relates to energy saving as well. Then the obvious one, low power, lossy, constrained networks. We've got, you know, almost an area worth of working groups that are working on various technologies. And then there are some, you know, sample technologies where, you know, I just had some background and interest in, but hopefully there'll others be added to it. And then, of course, the specific networks being built to actually support the generation of power. Smart grid, synchrophasor networks, that's a totally different approach. And then energy management, we had an EMAN working group, and later on there were ideas to do power awareness in networks, but they didn't pan out so far to form working groups, but there are some good initial drafts. Next slide. So yeah, so this document, just to repeat, if you're interested, please read it, provide feedback. If you're interested to contribute, please contact the authors. It would be great if this could become a community effort of the different areas of interest. And maybe there is a strange old mailing list that might also be used to discuss these things. Sounds like a recipe for possible collaboration. And yeah, that's it. Thank you very much.
Excellent. Let's see. Our next speaker should be Alexander. Yeah. Excellent. Okay, and let me get your slides into the right place. And stop sharing that, and then share the other slide. And
Hello, can you hear me? Okay, great.
am I in the right place?
Does it show? Oh, okay, it doesn't show here. Okay, well, okay, so yeah, so welcome everyone. So basically, this presentation is briefly to build on what Charles was just presenting on challenges and opportunities in green networking. And there are two drafts actually, which this presentation relates to. Please, next slide.
I just have a oopsie.
There should be two slides after this.
No, I mean they are. I'm just getting an unstable connection to the server. Let me. Yeah, I just got server unreachable. Let me connect to somebody. Let me connect to another device. Interesting. My apologies.
Okay, great. Okay, thank you. So really this concerns two drafts, one a problem statement and with challenges and opportunities in green networking, and one basically addressing starting to address one of the challenges, namely the metrics and the instrumentation. Next slide, please. Okay. So basically, yeah, this builds a little bit also on what Charles was presenting earlier. So the question is, why green networking or why sustainability actually? And obviously, this is one of mankind's grand challenges. And the question is basically, well, while network applications themselves are a key enabler, of course, of sustainability, what about the networks themselves? And clearly, the net zero mandates, etc., will apply to the network providers as well. Sorry, we lost connectivity again.
That was odd. How did we get that? I am getting an unreliable connection to the server after switching to my phone as a hotspot. So I'm curious. Wait, we seem to be coming back to life here. Okay.
All right. So let's continue. Let's see maybe 3 times the charm. So,
Absolutely.
Okay, anyway, so the question is what it boils down to. This is the question is also how can the network itself contribute to that, and what are ways in which the IETF and the networking at the networking level, how we can contribute to making networks more sustainable. And this may perhaps be a smaller factor than general hardware advances and deployment factors and antenna technology, but still, of course, there are certain things which are within our control. Next one, next slide, please. Okay, and so there are quite a few opportunities and, of course, challenges associated with them. We divided them into four different levels. Basically, basically going bottom up at the device or at the equipment level. It starts with providing proper instrumentation and visibility into the right types of metrics. Because unless you have visibility into this, all the other, well, then basically it's kind of like futile what else you are attempting to do. And this is kind of like our starting point there. But of course, it shouldn't end there. There are things that you could do at the protocol level, and basically a wide range of things, anything from basic traffic adaptation to lead to traffic characteristics which are more energy friendly, if you will, to enabling other mechanisms such as, for instance, fast discovery, fast state reconvergence. If you, for instance, dynamically take resources in and out of service, for instance, network addressing to have smaller tables to maintain, etc., etc. At the network level, there is the question of can we do more energy-aware routing, path configuration that takes energy and sustainability into account? What would be some of the control protocol extensions that would make sense there? And then finally, basically, also at the architecture level, one can look at some of those things as well, basically. For instance, when it comes to where do we place content, where do we place computation? Of course, people are already looking into this, but not so much with the energy or sustainability in the foreground, but there's certainly an aspect that plays a role there as well. And so there are many pieces and so forth that can contribute to this. Not one grand solution is required. Next slide, please. And so basically we want to generate basically more discussion on this. And so we have posted 2 drafts on this topic and would appreciate feedback, comments on this. So there's a problem statement and then basically metrics as the first specific work item. And we are also still looking for collaborators and actually the proper landing spot here in the IETF. Between the authors, we will have an informal side meeting on Tuesday from 1 to 2 in Salon 9. If you are interested in joining or in contributing, please join this meeting. And anything else, you have our contact information on the slides. That's all. Thank you.
So we have next speaker is Sophia.
Oh.
Yes, hi Spencer. I'm online though.
Oh, okay.
Yeah.
Excellent. Let me get back here and get organized, and I will
Okay.
share your slides.
There you go. There you go.
Okay, Sophia.
Yes, should I go?
Yes, please start. I am starting your clock.
Okay, thank you. So hi everyone. So today I wanted to talk about the challenges and opportunity of post-quantum cryptography for networks and protocol. Next slide, please. My name is Sophia Sell. Next slide, please. So basically, why should we talk about this? So as many of you might have heard, NIST ran a process to actually select new post-quantum algorithms, mainly algorithms that are safe in the in the face of the threat of quantum computers. And right now, this process have actually reached its first milestone, actually this month, and they decided to actually announce the selected algorithms that are going to be standardized for the key exchange process, meaning that that's the process in which you generate a key and you also share that key with a participant to arrive to confidentiality. And also they decided to standardize the algorithms for authentication, mainly digital signatures. This is just the first milestone. They're going to run the next competition for more digital signatures and also for a fourth run, but they indeed reached the first milestone, meaning soon we will going to be having a standardized post-quantum algorithms from the, basically from the NIST institution. Next slide, please. So why is this important for the IETF? Because one of the things that one might think is to just take the post-quantum algorithm, the signature algorithm, for example, and swap it in the place where a classic algorithm might have been. But this is not so simple because all of the post-quantum algorithms, in specific the signature algorithms, have bigger parameter sizes when compared with the classical counterparts. Here I just put a simple list actually compared with some classical algorithms. And when they actually are not bigger in size, they do have also bigger computational times in their signing or verification times. Next slide, please. Okay, so as I said, that's already a trade-off because you will have bigger sizes, you will have bigger computational times, and that in turn means that maybe we will be adding latency or increased times to the connections that we have, which means that the network and protocols that we're using are going to be affected. And also an important point is that right now, the majority of protocols that we use, being TLS or WireGuard or Signal, are mainly addicted to Diffie-Hellman properties, and the majority of post-quantum algorithms don't have all of the Diffie-Hellman properties that we love. And also certain algorithms that are now currently being standardized by the IETF, for example, in the PPM group, don't really have a post-quantum counterpart that can be attested for a high security, just like, for example, zero-knowledge proofs or OPRFs or threshold signatures do have post-quantum alternatives, but they have not been properly assessed for their security. Next slide, please. Oh, okay, maybe. Oh, there you go. Okay, thank you. Well, this is very important. As I said, it's something that we should start thinking about experimentation to see how much we can indeed add these post-quantum algorithms, or if we cannot add it, what kind of alternatives do we have? And this in turn means that maybe we should build designs that are generic for post-quantum algorithms, but also for other things. And this also in turn means that maybe the way that the protocols right now are working could potentially be changed to not only include post-quantum algorithms, but also other things that are needed. If you're ever interested, we're running a workshop on this specific challenge of putting post-quantum cryptography in network and protocols. It is going to be potentially co-located with the NIST workshop on November, so please reach out if you're interested in participating to it. And there's also currently a new IETF mailing list PQC that you can join and continue the discussion. Next slide. And with that, thank you very much.
So next person on the agenda is, I believe, Pascal. And yeah. Okay.
So we go.
Go.
Go. So this talk is about Internet of Secure Element, and it's a call to research and collaboration. Next slide, please. So to introduce the issue, to learn about secure elements, are small chip using bank card, SIM module, electronic passport, with height security level, highest security level in the market. There are today many small 816 CPU with 10 kilobytes SRAM and 100 kilobytes of non-volatile memory.
There's new generation with about 2 megabyte flash and 64 kilobytes SRAM, and they include a crypto processor. They use a legacy communication, which is based on serial and ISO 7816 protocol, but emerging chips support I2C and SPI. There have been re-encoded rules for packets up to 256 bytes. There are programming environment like Java card, 6 billion devices are deployed every day, 6 billion Java cards. And there are secure software management, but something called global platform in order to list the delete upload software. Next slide, please. So why connecting secure element to internet? It's very simple. We want online cryptographic resource for internet users, and we want to identify these resources by uniform resource identifier. The issue, there is no TCP/IP stack in secure elements, so we need additional processor to manage the networks. We need to support global platform for on-demand protocol. We need the defined protocol to access secure element resources. We need to define secure element naming, and we need to define attestation procedures for on-demand application. For next slide, please. So there are mainly the free IETF draft in order to support this. One is called RAX, it's an old draft, and this draft is enabled to support a global platform over TLS. The second one is called, second draft is called TLS-SE for TLS for secure element. It supports TLS PS key in secure element, and this gives a TLS interface to secure element, which use a TLS server name for uniform resource identifiers. And the third draft is attestation procedures, and it's in the Internet of Secure Element IOSC draft. And next slide, please. So at this moment, there are open software. One is TLS-SE for Java card. It works with Java card 3.04. It's available on GitHub. And the second open software is IOSC version 5, which works with Windows, Ubuntu, and Raspberry Pi. And it is an implementation of RAX and TLS front server. And it supports multiple communication interface like PCIe, I2SIM, and SIM array. And that's it. I'm done.
Thank you. Thank you. And our next speaker will be Hannes, who is talking about attestation within TLS. And I will find Hannes's slides real quick. Okay, you're on.
Thank you, guys. As mentioned, I want to talk about the new effort or new investigation we've been doing on using attestation in TLS. Next slide, Spencer. And as a short problem statement on why we are doing this, I'm sure you've been following the work on attestation and in the IETF and the RATS working group and some of the IoT work where we are trying to define mechanisms to enroll IoT devices into cloud-based services. And they typically want to see all sorts of information about whether the device is genuine, whether it has been cloned, what type of configuration it's using during boot, what software it's running on, etc. And all of this is covered in RATS with these entity attestation token and other similar mechanisms. And then at the end of the dance, once the device is authorized, it actually typically establishes a secure communication channel with the cloud-based service. And so next slide. It was kind of obvious to combine the two steps of attestation with TLS. And that's what we have been doing in a recently published document and also software we've been working on. The solution is simple to augment the DLS exchange with the attestation information and to provide a proof of possession. The software we are working on, which we'll hopefully will be able to release shortly, uses a combination of embed DLS with DLS 1.3, a platform agnostic library to access security hardware called BARSEC. And on the cloud side, there's a verification service we need to use, which colleagues of mine have been working on, called Verizon. And we basically munch all these three components together to accomplish a workable system. Next slide. And here's the document and pointer to the projects we are using. And soon you will also see the sort of this POC, essentially, or the stack. And if someone is interested in the details or wants to collaborate or has similar type of attestation systems, come and talk to me. Thank you.
Thank you. Next speaker is Lynn Hahn, who will be talking about the LEO satellite networking, the flying infrastructure for future internet. Let me find your slides.
Hello, everyone. My talk is LEO satellite networking infrastructure for future internet. This is a pretty big topic. I don't think 4 minutes is enough, but I will try to do my best to give most important information. Next slide. LEO satellite is most key components in the future non-terrestrial network integration. Because it can provide the shorter latency and higher bandwidth compared with other satellites or other space networking technology. And it can provide global coverage. Next slide. Why LEO satellite is so special? Because it's a movement. It's moving so fast. Unfortunately, this is originally a PPT has some video clip. If you're interested, I can give you, you can shoot me email. First is that 50% satellites moving to different directions as another 50%. This will cause the satellite networking becoming an interleaved mesh network and moving at a very high speed. Also including the self-rotation of Earth makes the movement is even more complicated. Second issue is that the link between satellite and ground station will keep flipping about 5 minutes. And the distance between satellite and the ground also keep changing. And also the combination is point to multi-point. And a huge number of satellite ground station link could be more than a million links. Last problem is that ISL distance between adjacent satellites is keep changing, and also those links will be swapping the direction at the polar area. Next slide. So IETF has done a lot of work for many years for satellites, but unfortunately, most of our work are focusing on other layers. For example, we have done DTN. It's not fitting to LEO. And we have done L4 works, which is about transportation layer. And we have done the coding for the satellites. Even we had a SATCOM side meeting in old IETF. Recently, we have many satellite-related drafts come up, but long existing home for those drafts. The first question we have to answer is that is the IP networking needed for LEO? Because many people challenge me, say Starlink doesn't use it. That's true, but We have many reasons to predict that L3 technology is still best for the LU satellite. First is the scalability. Second is the interworking with the internets. And the third one is that 3GPP has already expected that the satellite network is IP network. I have more material at the back of the slides. You can read it. Then we have to figure out what is the problem for the current IP technology. Actually, there are many problems, from addressing to routing, to traffic engineering and multipath and even mobility. We may need to reinvestigate and enhance it. Next slide. So what next? We plan to have a side meeting in next IETF, not this IETF, next IETF. So if you're interested, just reach me. And if you want to contribute or present something in the side meeting, just let me know. Thank you.
Phil, this is you. This is you. Let me bring you up your slides.
Okay. Well, while he's bringing up the slides, I'd like to really thank all the WebRTC folk. If it wasn't for the work that you'd done, the pandemic would have gone a lot worse. That said, next slide, please. If you look at the state of WebRTC today, this is what users are seeing. All that open standards-based goodness is hidden behind a proprietary walled garden. Next. Next slide, please. What users need is the ability to communicate with any other user, no matter which service provider is providing their WebRTC contact. And they should not just be able to choose a messaging provider and talk to everybody. They should be able to change their messaging provider at any time without switching costs. I'm a person. I am not your business model. We need messaging address portability. Oh, and telephone numbers? Who on earth thought of using telephone numbers for messaging on the internet? Next slide. Oh, and yes, be nice to have some security, not least because you know, the potential sponsor I've got wants some security, and I'm a security guy. Next slide, please. The problem I see in the current end-to-end messaging model is that all we get is end-to-end security. We think about securing the packets as they're going from the sender to the receiver, but that doesn't close down all the points of vulnerability where a hostile government can do something hostile. Next slide. The problem is that unless you control your own contacts directory so that you control the knowledge of the public key of the other party, that's a place where a warrant can be imposed to redirect calls to another endpoint. So you've still got end-to-end security, you're just going to the wrong endpoint. And the applications are another point. If you've got a sole vendor system in a walled garden, a government can and does and has go to a vendor and say, you're going to put a back door in or we're going to shut you down. Next slide, please. Okay, so how do we fix it? Well, the first thing we need to do is to complete the messaging stack. And I've been looking at WebRTC and, you know, I've got this threshold key infrastructure that manages public and private keys people across devices and makes it really easy for the end user. It's transparent security. So what I want to do is to take my security stuff, my TKI, and bolt it on top of WebRTC. The user will control the contacts catalog, so that cannot be tampered with. And the user, because this will all be an open specification, the user can choose, hopefully, between multiple application providers, not just my prototype. And that removes a single point of failure. Next slide. Okay, so I'm going to be here till Friday. If you're interested in this type of project, please talk to me. Tell me. I'm not a WebRTC person. I can see how to do it. I've kind of sort of got my prototype running, and I'll be hopefully running that prototype by London. But I would really appreciate help on choosing the best path through WebRTC and the best of breed things to go to market with. So thank you for your time, and mathmesh.com has the further details. Thank you.
So next speaker is Lijun Dong, who's talking about challenges in operations and control networks. I will find your slides.
Hi, my name is Lijun Dong. I'm going to present on operations and control networks. Through this presentation, I mainly want to call for your participation in the side meeting we're going to host on OCN tomorrow lunchtime. Next slide. As you know, automation grows and becomes more dynamic. The factory floors will require more sophisticated controllers with more processing time, more processing capabilities, more flexibility, and more interoperability support. And the controllers sitting in the cloud, such as virtualized PLCs, would become more and more popular. As another use case in remote driving, a remote human driver actually controls or operates a vehicle from a distance through communication networks. And remote driving is extremely useful when autonomous driving becomes short or force short and in some hazardous environment where human cannot access. So such factory automation or remote driving use cases do require network to guarantee the end-to-end latency, and also need to identify what are the most urgent packets and treat them with some more priority and avoid them being dropped during transmission. So those different vertical, like industry vertical, do share some common operation of behavioral operations in control systems. So there is a controller which interfaces with the sensors to collect data and then interfaces with the actuator to send a command. But if those end devices are networked, there would have some issues. So those common elements or abstract elements by using OCN actually enable us to have discussions on those requirements and issues. Next slide, please. So we define OCN as operation, like it's a short name for operation and control network. It's an interconnection of a few devices and their controllers for the exchange of data to cause and monitor change to the end equipment. Next slide, please. So what are the issues we want to consider in OCN? So with the controllers sitting in the cloud and there are more and more field devices being deployed, maybe it is time to explore the opportunities and the methods to use IP to interconnect the controllers and field devices and to build OCN. And high precision communication are needed because you want to guarantee the key performances and to provide a more granular QoS to build OCN. And there are multiple types of media such as 5G radio, Ethernet, all those kind of different media, and as well as there are multiple types of field bus communication protocols. We want to use OCN to convert them in a large scale. With some reference model. And then addressing needs to be supported as, auto configuration and also heterogeneous addressing. And we also need to build message types. For example, what are common characteristics between the controllers and the field devices? And the last but not least is the security. We want to ensure the security of communication between the field devices and the controllers. And next slide, please. All right. So we are going to host a list meeting on OCN tomorrow lunchtime in room. Actually, this is the wrong slide. We are going to host a side meeting Horizon at rooftop level. Okay, and this is the website, web link we can share. And I guess I did a bad job.
Yes. Now, yeah.
Most importantly, come to the side meeting.
I was just going to let her put up the sound check slide where the meeting is. Next speaker is Arnaud, who is talking about enterprises and organizations needing help from ECH work on how to organize their operational security. And you,
hi there. Can
Arnaud,
you hear me?
You are Renaud. Yes, absolutely.
Okay,
we can hear
very
you.
good.
We can hear you fine. And let me find your slides.
Thank you, Spencer. So good evening, I guess, for you guys. And sorry for my voice. I have a bad COVID, so hopefully not cough too much. All right, so this is, we prepared a paper on ECH for enterprises. It's not a critique of ECH. We are trying to look beyond. The situation is pretty simple. Enterprises are facing a set of requirements and constraints, compliancy, risk, threat landscape, and since 30 years, they evolved the defense and operational security from the old X.800 to Zero Trust to SSE to Mesh, etc. And they need the need for network security controls and selective decrypt, for example, with for data loss prevention. So if we remove the access to the SNI, ECH is pushing security to the endpoints. Now, unfortunately, in the paper, we show we cannot trust the device and not trust the browser. We found enough evidence of manning the browser attacks. And worse, if you really want to protect the people, you not only need to access the SNI, but you need to read the entire page. That's the only way to detect the attack. So the browser cannot be judge and party, which means how are we going to do security? So, or perhaps ECH is pushing a security model that goes in the client-facing server, so that would make the client-facing server a middle box. Is it an opportunity actually to find a solution between the different parties? And that's really the question we are trying to address. Next slide. So it's pretty simple. We need first clarification on the client-facing server, so the backend server. Is it really left to just implementation, or do we need the protocol based for the client-facing server to the backend server? In this case, we are back to middle box problem. If ECH constitutes cannot be judge and parties, how do we integrate a third-party security component? And is there a form of recognition acknowledgement of enterprise operational security problems? Both answers can happen, and they will lead to different development. So if you are interested to find a way forward here, please join. In fact, I made a mistake. It's not 1:30 p.m. It will be noon 30 p.m. On Tuesday, and you can contact me. Thank you.
Thank you. And our next speaker is Gusama, who is talking about a data-driven approach to tackle network diversity with heterogeneous protocol configurations. And let me find your slides.
Hi, Spencer. So yeah, all right. I'm a graduate student at Brown University, and today I wanted to share some research work with the broader IETF community to see if anyone is interested. So next slide, please. So websites typically use CDNs to deliver their content efficiently to the end users, and they have these clusters of servers spread across the globe, typically called CDN edge. And at the edge, we have protocols like TCP and HTTP that dictate the data transmission rules. So there's multiple options available. We have multiple types of HTTP and different HTTP configuration. And similarly for TCP, we have different congestion controls like BBR, Cubic, Reno, and multiple other options such as congestion windows. And it's the job of operator to select the configuration that are expected to maximize the performance. Traditionally, the operator selects one set of configuration, which are then homogeneously used for the entire user base. And in this work, we asked this question that, is this approach really optimal? So can you go to the next slide, please? So in fact, when we look at the client tier or the user base, we see that there's a diversity there. Users come from different regions, have different last mile connections like 2G, 3G, 4G. And it's a problem because the performance of the protocols is sensitive to the type of network and devices. So assuming that an edge has 3 users, one with low latency, one with high bandwidth, and one with high loss network paths, the choice of optimal configuration can be very different based on the type of network. And in fact, we did some measurements at scale that actually showed that there's a tremendous opportunity here. There's an opportunity to improve web performance. And the figure here shows the improvement in page load time for websites, and there's up to 70% improvement at tail if we are using some sort of an oracle to configure the right configuration on a per connection basis. So next slide, please. So in this work, we propose a system that optimizes web performance by systematically reconfiguring the networking stack. So basically taking into features such as a user's network, the device, and website. Our system selects, predicts the right set of configuration that should be expected to maximize the performance. Next slide, please. So we propose 2 changes to the existing CDN architecture. We first propose a data path component that runs at a server level. And it is basically a modification of today's networking stack, and it allows a flexible reconfiguration so that we can tune things like TCP congestion control or HTTP on a per connection basis. And the second component is a global control path that uses some algorithmic and some machine learning magic to try to predict the right set of configuration that can be used. So basically, this runs in a data-driven sort of model. It ingests data from the servers and models the performance of different configurations. Next slide, please. So in this work, we asked this question that since it's hard to make or design protocols that are generalizable across different types of networks and devices, perhaps this is the right time where we should invest and design systems that can make our networking stack architecture more flexible so that our networking stack can dynamically adapt to what the users have on their end. So if you are interested in learning more about it, please reach out to me or my advisor, Theo Benson, or you can take a look at our NSDI paper. I'll be also in Philadelphia from tomorrow, and if you want to talk more about it, we can definitely do that. Thanks.
Thank you. Yes. Next, we have Jake talking about multicast quick. I will find your slides.
All right, thanks. You can probably just go to the next one right away. I'm Jake, and I'm talking about multicast quick. Yeah, next slide. The basic premise, there's a draft. Go ahead and read it. The basic premise here is that unicast is a real problem. I've been working on this for a while. I've been talking to a lot of ISPs. Got some ideas about how to get them to transport it, but then the next step is what are we going to transport? Next slide, please. And the basic idea is IP multicast is what we want to use. So we proposed a way to let Quick use that. Next slide, please. So just, I'm not going to go over the whole thing, of course. Read the draft. But the basic idea is you're still going to have a single unicast connection between any two endpoints. You're going to be, the server is going to tell the client, hey, join these channels. The client's going to be sending ACKs. So the server knows what channels it got, what data it's getting from these channels. And the multicast is going to be used for server to client only. So this matches up with the security consideration stack that we presented in Sec Dispatch in 112, we think. And we are looking to get a prototype running. Next slide, please. So I just wanted to let people know about it. I'll be talking about this a little bit more in the Quick Working Group on Thursday. We've got, we've got the draft. We'd love to get feedback on it. Anybody who wants to review. We've been working on an implementation with the W3C Multicast Community Group. If you're interested, you can join us there and contribute to that. My email is there. You can ping me, and please come to Quick or find me anytime this week and give me comments, and I'd love to have them. Or my co-author Max here, raise your hand. Anybody can find either of us, and we will take all your feedback and do what we can with it. Thank you very much.
Last speaker will be Stuart Cheshire, who will be talking about network latency, why it matters, how to measure it, and what to do about it. And I will find your slides in just a second. Okay. Perfect.
No, that's not
Nope,
it.
that's not you. I will now go find the next slide, which is actually the right slides. I think I just clicked on the wrong one, sorry. I don't know why that keeps jumping down, but it did.
All right, that's better.
Okay, excellent.
My name's Stuart Cheshire, and for the last 4 minutes today, I'm going to talk a little bit about latency. Let's move on. We're all very used to thinking about performance in terms of throughput. Everybody knows how many megabits their home internet connection is, and that's good for big downloads. But for everything else that we do, for maps, driving directions, weather forecasts, every time you're sitting watching an app with some little spinny wheel, waiting, it's not because you don't have enough bandwidth. It's because you have too much delay. This affects lots of things that are very obvious, like online gaming, video conferencing. It affects many other things. Even if you're watching a 2-hour streaming video, if you want to skip to another chapter, then suddenly it's the latency that affects the performance of that. Okay, next, please. Last year, some of my colleagues at Apple put out a new measurement tool. The instructions for how to enable it are at this link, which is in the PDF on the website. And when you enable that, if you tap on the I button, then, yep, next, please. Then you see a button for diagnostics. And when you tap on that, it will show you the responsiveness of your network. We present this in round trips per minute because most people like metrics where more is better. And milliseconds is a fairly abstract concept to a lot of people, even for us in this room. How much is a millisecond? Well, it's too small to notice. Does it really matter? So we wanted a number that is more, people relate to more easily. Next, please. Since last year, Waveform has put out a really good buffer bloat test. Professor William Hawkins from University of Cincinnati has got an open source implementation in Go. And more recently, Ookla, makers of probably the most popular speed test app and website on the internet, have added a measure of working latency. So if you're not staying in the IETF hotel, when you get back to your hotel tonight, try out the Ookla speed test on your hotel. Try it on your mobile phone on LTE and 5G. Try it at home. Try it at work. You may be very shocked by the results. Until now, speed tests have told you the idle latency in milliseconds, but that tells you how well your network works when no one is using it. That's not very useful. What we want to know is how well your network works when it is being used. And speed test will now report this. So we know there's a problem. What are we going to do about it? The answer, in my opinion, is L4S. It's a new method of doing congestion control in partnership between the endpoints and the network. It's called low latency, low loss, scalable throughput. And I can't explain all of this in one slide, but the summary is it works to keep queue short. By keeping queue short, we keep round trip delay short. As soon as a queue starts to build up at the bottleneck link, it uses ECN marks to tell the sender to slow down. Next one, please. We had a lot of representation at the hackathon. Let's move through these pictures quickly. Go ahead, next, please. We had 2 CMTS racks set up. Next. We took over a big chunk. Go on, next one, please. We took over a big chunk of the hackathon room. Next couple of slides, please. We had a whole bunch of equipment piled up on desks, a lot of energy. So to learn more, there's a great BITAG report. If people ask you about latency and you don't want to spend an hour explaining it yourself, point them to this report. If you prefer video, there's an Apple Developer Conference presentation, about 15 minutes long, by my colleague Vidi Goyal, who's here today. And last slide, please come to, can you go to the last slide, please?
Okay.
Can you put up the last slide?
Oh, yeah.
Okay, come and see us on Monday and come on Friday if you're interested in the measurement. Thank you.
Thank you. And let's give yes, the actual applause for Stuart, and then let's give a round of applause for all of our speakers today. Thank you all for coming, and thank you for your patience as I figured out what I was doing, which, yeah. Enjoy your IETF and do the right thing. Bye-bye.